In this video, we will learn how to predict if a molecule can exist as Z or E isomer, and also how to draw E and Z forms. In order for a molecule to be able to exist as Z or E isomer, it must have a C double bond C. But not all molecules that have double bonds can exist as these isomers. So let's take a look to see how we can predict this. Let's say that I have a C double bond C, and let's say that this carbon is attached to a hydrogen on one side, let's say a methyl group on another side, and this carbon, let's say, is attached to bromine and to let's say iodine. So can this molecule exist as Z or E isomers? In this case, what we have to do is we have to look at each carbon from the C double bond C separately, and we have to ask, is it connected to two different groups? So is this carbon connected to two different groups? It's connected to a hydrogen and a methyl. These are different, yes. Is this carbon connected to two different groups? It's connected to bromine and iodine, yes. So in this case, this molecule can exist and is capable of Z-E isomerism. Let's say that instead of a methyl group here, there was another hydrogen on this carbon. Now, this double bond cannot be identified as Z or E because this carbon is attached to two of the same groups. So whenever we have molecules where we have a double bond at the end, for example like this, these molecules are not capable of being Z or E because this carbon is attached to two hydrogens which are the same. So with that in mind, let's go ahead and look at the first molecule. Does this molecule have a double bond? Yes, it has a C double bond C. Now, is my C double bond C is each carbon attached to two different groups. Usually we would draw this molecule out, but in this case right away I can see that this carbon is attached to two methyl groups. So without drawing the full molecule, I can see that this carbon is attached to two methyl groups, and if it's attached to two of the same groups, that means it is not capable, this molecule cannot exist as Z or E isomer. So without even drawing it out, we can go ahead and skip it. Now let's look at this molecule. Again, we can see that this carbon is attached to two methyl groups just like before, so this double bond would not be capable of being identified as Z or E, but this double bond is interesting. So what we're going to do is we're going to rewrite our molecules to see what is connected to what first, and then we will write line angle structure, and then we will try to determine if it's capable of Z-E isomerism, and we will draw easy forms if it is. So let's go ahead and see what this molecule looks like. I'm going to start with this carbon, and it's attached to two methyl groups. So I will put one methyl group and another methyl group and a double bond to this carbon. Now I'm on this carbon, it's attached to a hydrogen and a CH2, which is attached to another CH2. So I did this, which is attached to a carbon, and it has a branch, it has a methyl branch. And whenever we draw these out, we just need to remember that every carbon wants to have 4 bonds. So we will just draw it out to make sure that everyone gets 4 bonds. And you can also see my videos on drawing line angle structures from condensed structures and understanding these condensed structures. So we have CH3, and then we have a double bond, we have CH, and then we have CH2OH. Now, when we look at the first double bond, like we said before, it's attached to two methyl groups, so this is not going to be capable of EZ. But looking at this double bond, we can see that the carbon on the left is attached to a methyl and this whole molecule, and the carbon on the right is attached to a hydrogen and this whole molecule. I prefer to draw my molecules as bond angle structures, so that's what I'm going to do next. And I'm going to just number my carbons: 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 carbon in this chain, and I'm going to draw an 8 carbon chain. 1, 2, 3, 4, 5, 6, 7, and 8. And then I'm going to just attach everything that I have not attached yet. Between 2 and 3 I have a double bond, and on carbon 2 there is a methyl group, so I'm going to have a methyl group here. Then on carbon 6 there is a methyl group also, and there is a double bond between 6 and 7. And then on carbon 8 I have an OH. So this is my molecule. Now I was asked to draw both E and Z forms, and what I'm going to do next is I'm going to figure out whether I have drawn E or Z form, and then I'll draw the other one. How do I do this? I look at my double bond. Let's go ahead and highlight my double bond. And when I look at my double bond, I will look at each carbon that has the double bond. I will look at each carbon separately. So let's look at carbon number 6 first. So forget all of this side, and we're just looking at carbon number 6 and everything to the left of it. I ask myself, what 2 groups is my carbon number 6 attached to? And I will go atom by atom, and I will circle the atom that has the bigger atomic number. I may have to go more than atom by atom. I may have to go more than one atom to see what the difference is. So let me show you how to do this. Here my carbon number 6 is connected to a carbon, and here it is connected to a carbon also. So far I see no differences, which means I have to keep on going. This carbon on carbon number 6 is attached to 3 hydrogens, and the carbon 5 is attached to 2 hydrogens and another carbon. So this side wins because this carbon is attached to another carbon and this carbon is not. I am going to go ahead and circle it. So from carbon 6 I'm circling this part. Then now that I'm done with carbon 6, I will forget about this side and I will look at carbon 7 separately and what is attached to this carbon. Right now I see that I have this group attached to it. Remember that every carbon has 4 bonds, and there is a hydrogen that is attached to carbon 7 that I will draw out. Again, I need to go atom by atom until I find a difference. So here I go and I see hydrogen, and I go here and I see a carbon. Between hydrogen and carbon, carbon has the bigger atomic number on the periodic table and it wins, so I can circle it. Now that I have circled the 2 groups, I am going to ask, are they on the same side of the double bond or are they on opposite sides of double bond? So I'm going to draw a line through my double bond and ask, are these 2 groups on the same side of the double bond or opposite? I can see that they're on opposite side, and when the 2 groups are on opposite side, this configuration is called E. An easy way to remember it, Z, I remember it's like zame, same. So that's how I remember it. If you have Z, then you will have 2 groups on the same side of the double bond, and for E I have 2 groups on the opposite side of double bond. So all this work, and I figured out that this molecule has E configuration. I have to draw both Z and E isomers. So what you can do next is you can redraw the molecule, and I'm going to choose one carbon where I will switch the 2 groups. So let me redraw this molecule until I reach carbon 7. So let's go ahead and redraw 1, 2, double bond here, 3, 4, 5, and 6. 6 has a methyl group, double bond, and now I have 7. Now that I got here, I'm going to switch where each group is. So instead of hydrogen being down and CH2OH being up, I'm going to switch them. I will put hydrogen up and CH2OH down. And what that will accomplish is that it will put my 2 biggest groups on the same side. So these 2 groups are now on the same side. And this configuration will be Z configuration. This is Mayya. If you like this video, please subscribe and comment below.